Does everyone see my? Oh, no, no one can see my screen yet. Does everyone see my screen now? It should say what is programming as the first slide. Yes. Yeah. Good. All right. Awesome. Cool. Yeah. So I mean, we're just gonna go through a few slides that's gonna cover the layout of what the next next 6 classes are gonna look like for us. Um, But before we do that, I just want to kind of do a really quick primer on what is programming, right? That's what we're all here to learn, and there's a lot of questions around it. And at this point, there may be more questions than answers on your part, and that's perfectly normal. Um, so when we talk about programming, I basically think that programming is just a fancy way of saying what is problem solving. Ultimately, programming can take a variety of forms, and a lot of what is portrayed about programming in the media, it focuses a lot on the specifics of language and technology, which are all very relevant aspects of programming. But fundamentally, all programming is saying, hey, I have this kind of complex problem. Can you figure out a way to solve it for me? And more often than not, can you solve it for me at scale, right? Which means, can you solve this problem thousands of times or millions of times? If you think about kind of one of the biggest tech companies out there, Google, right? Like they use programming, right? But really, they're using it to solve a problem. The problem is, how do I categorize all of the world's information and make sure that when you have a question, we can get that information to you, in microseconds, really. Um, so when we think about programming, you know, especially when you're first starting off, I really would caution you to say, hey, like don't get too stuck on saying this is a language or this is kind of this is like the tech stack or this is a tool, but more think about like how am I solving this problem? Like what is my approach? And think through it kind of from a very logical and very analytical perspective. Programming, for the most part, is concerned with taking information, modifying it, transforming it in some way, and then giving you back the answer. A calculator is a great example, right? I give it a couple numbers, and if I wanted it to add up for me, I give it those numbers, and the calculator is just going to take those numbers, add them together, and give me the output. It involves logical analyses and decision making, and it's repetitive. And the key thing that I'll note here is that whereas computers are very good at solving very complex problems very precisely many times with very high accuracy rates, the one thing that computers are really bad at is ambiguity. And more specifically, the example I always give is if someone asks you, hey, who is the eighth president of the United States, and you don't know, you might tell someone, just Google it, right? And that seems like a very simple command on the surface. But if you really think about what that means, right, there's a lot of context behind those 3 words. Just Google it. It implies you're asking the person to go to a computer, go to Google, type in their answer, and look it up, right? That's an example of a command that works very well in the human language, but it actually doesn't really work very well in the computer language. Why? Because computers actually need very precise instructions. They can't infer things from you and try to figure out on their own, right? They need you to tell it exactly what to do every step of the way. Once you do that, they can then do those processes lightning fast with high accuracy rates. But the short of it is just that with computer programming, you cannot tolerate ambiguity, right? And so when you're first learning to program, especially, always make sure that you know what the problem you're trying to solve, and always make sure that you know what you're asking the computer to do. One common trap or one common mistake that a lot of beginner programmers make is that they kind of write some code and they just hope that it works, right? They hope that it works, and when it doesn't, ask them, oh, so what's your code doing? And they're like, I don't really know, right? That's kind of the worst case scenario here is that for a machine or a computer that requires very precise directions, you give it directions that you yourself do not yet understand, right? That's kind of like the worst case scenario. So that's something that we're going to be focusing a lot on over the next 2 weeks. And the other thing is there's this kind of image of programmers being kind of people whose only form of sustenance is energy drinks in a room by themselves for like 18 hours a day coding, right? And that does happen from time to time, but like for the most part, programming is a very social and a very creative process. A common question that gets asked in programming is this right? Right? And the counter to that is always just, well, does it work? Obviously, some solutions are more efficient, some solutions are more elegant than others, but especially when you're first learning, the best answer is the one that works, right? To make sure that you understand at least one way of how to solve a problem. If I ask 2 programmers to build a feature for me that does the same thing, for example, if I ask 2 different programmers to say, hey, can you build a like feature on Facebook? Both features might do the same thing, but I can guarantee you that the way they get there in terms of the background processes, the architecture and everything will be very different. And that's perfectly normal because software development does allow a lot of flexibility and a lot of creativity, and anything that's worth building at this stage is going to be something that you build with a friend or with a team or with a partner, right? Very few worthwhile things really are built by themselves. If you think of like something like Facebook or Google, right? There's no way any human being can build that by themselves. You do it through collaboration, and you do it through teams making a collaborative effort towards building something really, really big. For this curriculum, we're going to be basically covering fairly traditional front end development. What does that mean? It just means we're going to build a website that we're going to give you the tools to build a very basic website that other users can see and use. We will be focusing primarily on the front end, so we'll be primarily focusing on the part of the website that the user can see and use, as opposed to the back end, which has to do with servers, databases, and kind of how you make requests and all of that. We're going to stay largely away from that, but that will be something that we'll talk about in the more extensive full stack curriculum. The way we divide up website building is amongst these three components: HTML, CSS, and JavaScript. HTML stands for that thing that you'll never need to know ever again. And essentially, you can think of it as a way for us to kind of create and organize the actual components of a web page. If I have a line of text, that's a component. If I have an image or a logo, that's a component. If I have a picture or a link, that's a component, right? HTML lets you create and move around the basic components on the page. Yep. CSS, on the other hand, becomes the way to make everything on your website look pretty, right? So this could do with fonts, it could do with colors, backgrounds, positioning, basically all the things that allow you to take a website and make it stylistically attractive, and also some very basic functionalities that lives in the realm of CSS. And then last but not least, we have JavaScript, and this may be the one that you've heard most about. It's probably, I would say, kind of a more fully fledged language relative to the other two. JavaScript can be used for a variety of things. Within this curriculum, we're talking about it in terms of it adding additional functionalities to a website that makes it much smarter, right? And when we say smarter, we just mean it means it can interact with the user in some way. So if you've ever been on a website where if you hover over a button and a drop-down menu comes out, that's an example of JavaScript interacting with you, right? It knows where your cursor is, it's detecting your actions, and once you do something, it does something in response to kind of hopefully add more value to you for the website. And so if we were to think about a website with the website as human body, then the HTML components, those become the skeleton or the backbones, right? They really hold up the actual pieces of the website. The CSS becomes the skin and the clothing, right? All the things we put over the body to make it look pretty and attractive. And then last but not least, we have JavaScript, which is the nervous system or the brain behind the website. This is what makes the website really powerful and really operational. So across this curriculum, today we're going to be covering HTML. Tomorrow we'll be covering CSS. On Wednesday we'll be covering part 1 of JavaScript. Next Monday we'll be covering part 2 of JavaScript, and the next Tuesday we'll be covering part 3 of JavaScript, and we'll wrap up next Wednesday with the final project. So we obviously spent a lot of time on JavaScript because it is kind of like, I would say, the richer part of this curriculum in terms of thinking about problem solving and more algorithm based work. But also means that these first 2 days, especially, we're essentially trying to cover a language per day, which is quite aggressive. So if you feel like things are a little bit overwhelming, that's perfectly normal way to feel. But the purpose of this curriculum, just to be very honest, it's not to say like, hey, we're going to make you very technically deep experts in any of these three languages. We just wanted to expose you to the basics of web development, and more importantly, want you to kind of get a feel for what software programming is, right? We want you to make a decision on, do I want to pursue this further? And it's not, and oftentimes with most people, it's not a question of, are you able to do it? It's more like, do you like doing it, right? Do you like sitting in front of a computer and solving problems, right? Do you like situations in which you don't quite know what the problem is and you kind of need to figure out day to day, as opposed to a situation in which maybe things are very transparent and you kind of know what you're dealing with all the time. And so as you go through this class, don't get too hung up on maybe there's a lot of details you haven't quite learned yet. Try to get a feel for, is this something that I really like, and is this something that I want to kind of keep pursuing on down the road? So that's a very basic high-level overview of the curriculum. Are there any questions about any of these three, and I'm going to go really deep into HTML in just a minute. But are there any questions around how we're laying this out, or the order of the curriculum, or anything around the class over the next couple of days? Everyone good? Everyone's good? Okay. All right. Well, most of you don't have a camera on, so I can't see you or hear you. So I'm going to assume that. Awesome. Thank you. Cool. So let's talk about HTML. Okay. I.e. the skeleton of the web page. So today we're going to talk about how to write HTML, how do we see it, and to do so we're going to discuss a little bit around the basic building blocks of HTML, i.e. the elements. We're going to talk about some basic element formats, and then we're going to talk about things like attributes that allow you to add more functionalities to both links and image tags too. Right? So once again, very, very basic. A lot of the things we're talking about in this class, or sorry, in this presentation, they're going to be sections they're going to be sections. They're being covered by sections in the reading in the workshops, which we'll see after the presentation. And the goal here is not to say we're going to just repeat everything that's in the reading. The goal is let's just cover everything in the reading, but at a fairly high level, so you make sure you kind of understand roughly what you're looking at. But then obviously when you get down to the workshops, we want you to actually do them and kind of explore all of these concepts in a lot more depth. So if I was to build a website about something very basic, it very well could look like something what we see on the left side here, right? I have some big headers, I have some text, I have some images, and that looks very clean. However, if I was to take a look at how the HTML for this website looks, it actually might look like something more on the right-hand side, right? On the right-hand side, effectively, is the raw HTML for what we see on the left. And so one of the things we're talking about today is, well, how does the code we see on the right-hand side correspond to code on the left-hand side? The right-hand side may seem a bit overwhelming at first, but if we just kind of slow down and take a look at it, one thing you actually notice very quickly is that, hey, like a lot of the things match up fairly closely, right? Like on the left-hand side, I have this big header called How I Learned to Code. Well, that exists in line 2 on the right-hand side. And so if you stare long enough, you'll start picking up some of the patterns that we see. And that's intentional, right? HTML is a language, right? But it's not meant to be opaque. It's meant to correlate very closely with what we see show up on the web page, on the web page itself. Obviously, one thing that we do see on the left-hand side that we don't see on the right-hand side is the left-hand side. It's very pretty, right? There's a lot of styling, different sizes, different fonts. On the right-hand side, all the elements look the same. I could type that out on Notepad, on Microsoft Word, on any platform, and that's by design. It's because we want the web design process to be universal across a variety of different platforms. So how do I actually make this website, right? Well, like we kind of hinted at earlier, every website is just, or every web page really, is just made of components, made of pieces, right? And we call those things elements. Everything on this web page is an element, from the big How I Learned to Code header, to the 2 paragraphs of text, to the step 1 HTML header, to even the images on the bottom. Those are all elements. And when we say elements, we just mean they're pieces of code that once we write, they effectively are the blueprint for creating something visual on the page. And so some of the most common elements that we're going to see, right? One is called the P, or stands for paragraph, the paragraph element. And the way we create an element is kind of with 2 bookend, what we call tags. In this case, on the left-hand side, we have the P tag, the open tag, and on the right-hand side, we have the P tag, the closing tag. And we know it's closing because in between the carets, we see the P there, but for the closing tag, right before the P, we see the backslash. And so if I write this element somewhere on the page, this basically tells HTML, hey, I'm creating a paragraph element on the page. Similarly, the tag format is what we use to create almost all of the major elements on the page, right? And so here we also create another element. What's this one called? As you can probably guess, it's the text in between the carets, more or less give it away. It's called the H1 tag. The H in H1 tag stands for header. and they basically help HTML tell you, hey, this tag is going to be a header element, aka it should be bigger and bolder than normal plain text. The way that HTML does headers is that there's 6 categories of headers: H1, H2, H3, i.e. all the way down to H6. And kind of counterintuitively, the bigger the number, the smaller the header, right? So here we have an H1, which is the biggest header tag that HTML has to offer. And we see on the left-hand side, we have our open tag. On the right-hand side, we have our closing tag. And so in both of these scenarios, when I put some text in between these tags, whatever I write in between these tags are basically text that is going to be affected by the criteria or the rules of this tag. So when I write hi in between the two p tags, that basically says, hey, make this text kind of small, even text, like you see normally. On the right hand, on the second row, then if you see it, I still wrote the same hi in between the two h1 tags, but h1 says, hey, make this text big and bold. And so what that means is, on the right hand side, when we actually render the image of the tag, we see it being a really big, bold text. Okay. Everyone good so far? These are just elements, and all we're doing is writing text in between them. And even though the HTML we see on the left-hand side has no, there's no bearing on sizes and fonts and boldness, when we actually render, i.e., when we actually show these HTML elements on a web page, then the sizes, the bolds, the colors, those do come across. And then last but not least, we also have some tags that are a bit unique in the sense that they don't have a open tag and a closed tag. It's just one tag. And so we call those self-closing tags. And the image tag is probably the best example of this. Here we have an image tag. We see the open caret followed by img, tells us this is the image tag. But if we look on the right-hand side now, there's no closing img tag. It's just backslash and it closes right away. And the reason for this is because if you think about an image tag, well, we're not feeding it any more text, right? We don't need a bookend, a start and an end date. Or a start or an end point. We just need to say, this is an image tag. And the only thing the image needs to know is, hey, where's the image that I'm showing, right? Where is it being stored? And so that's why for the image tag, we don't need 2 tags, we just need 1. And in this case, we actually feed the image tag something called src, which stands for source. And we'll talk more about that when we get to the links and attribute section. And so when I show the image tag, it can show up as a logo on my side. And so if I actually go back to the previous page now, right, we go back to kind of how this web page looks. Let's just walk through as a group and kind of translate some of this stuff, some of this HTML now into what we see on the right hand side. Oh, sorry, on the left hand side. So initially, we have our body tag, and just kind of for now, just think of the body tag as kind of this empty container. It doesn't have any special properties. It's just a way to hold all of this code together. We go to move on to line 2, and we see an h1 tag. Remember, h1 is our biggest, boldest header, right? And so we have an h1 tag, we have the text, how I learned to code, and then we have our closing h1 tag. And so when I look on the left-hand side, yep, there we go, how I learned to code. Very top of the page, big and bold, okay? Afterwards, right after the h1 tag, we have our p tag, which stands for paragraph text, and that's just what we use to show text, right? And here we truncated the text with a ... But essentially, all I'm saying here is, hey, take all of this tag that starts with lorem ipsum and just show it as a paragraph on the left-hand side. And indeed, that's what we have, right? A bunch of gibberish or Greek or whatever it is. Then after that paragraph, we have our h2 tag. Does everyone see that? On line 6. What the h2 tag is saying is, hey, take the text, step 1, :HTML, and make it a big, bold header 2, but slightly less big and slightly less bold than the first one. And so that's why step 1 HTML is also a header, but it's a bit of a smaller header. After that, we have another p tag and another paragraph tag of random text. And then finally, on the very bottom of the page, we have 2 image tags that help us load up 2 images. Okay, and so you can kind of already start to see how, without necessarily too much detail or depth, we can already start translating already start the translation process of how do the elements on the right hand side kind of materialize into the web page that we see on the left hand side. Are there any questions so far? Sorry, was that a question? Cool. All right. Well, if everyone's good, sorry, I missed the last 1 second of what you said, Holly. Is everything good? Okay, perfect. Great. Yeah, no, you're good. Okay, are there any questions before we move on? Because this is building elements. Sounds very basic, but this is like the foundation of what we're talking about, right? So if you have any questions here, please ask. Yeah, and also just kind of a quick note, we'll talk more about this when we talk about positioning, but it's not a hard and fast rule. But notice how the by default the HTML kind of shows top down, right? The first element on the page renders first, followed by the next element, followed by the next element, so on and so forth. So generally speaking, HTML goes from top down, left to right. But obviously, we're going to see some exceptions to the rule once we talk about kind of more robust positioning of the elements. So then we go back to this again. These are how the elements looks. Okay, so now we've created the elements. Let's next talk about how the elements associate or interact with each other. And to do that, we can start talking about something called parent and child relationships. In computer programming, the family analogy is actually very powerful. We use this idea of a family tree for a lot of things, and so you'll see this parent-child analogy come up quite a bit. Okay, so sorry, I think I just got a message from someone. Okay. Um, okay. So one of the other elements that we're going to talk about today is something called the UL element. UL stands for unordered list. Okay. Unordered list basically means, as you imagine, just a list of bullet points, right? It's not numerical. There's no sequence there. It's just a collection or a list of different items. Um, if we think about if I think about the construct of a list as like a container, or in this case, a parent element, well then each of the individual list items that we show up in the unordered list are going to be an element that's going to be captured under the li tag or list item tag. Um, and so whereas every list item belongs to this parent of an unordered list, so that just means that if we want to talk about it from a family tree perspective, then every list item is a child of the parent, and therefore every list item becomes siblings to each other. This is just a lot of words to describe that. A lot of times we talk about the organization or the hierarchy of the HTML elements. Not every element exists independently. Sometimes some elements belong to other elements. And so if we want to take a look at an example of this, we can see in this case there's this code here, right? We can try deciphering this really quickly. We still have our body tag, right? On line 1, it's our open body tag, and on the very last line, it's our closed body tag. So this is a container for all of our HTML. On line 2, we have our h1 tag, which has it means header 1, and it has the word list in it. So we're gonna make a big header. And then secondly is after that we have a UL tag, an unordered list tag on line 3, and then we have the closed UL tag on line 6. So everyone see that? And in between the two UL tags, notice how we have two list item tags, right? The list item tags follow the same convention as all the other tags, right? We have an open li tag, we have the word 1, and then we have a closed list item tag, right? That basically says, hey, that line and line 4 there, that's a list item element. And then line 5 will be another list item element. And so if we actually draw this out in with kind of this like parent tree visual, this is how the code will look. We have a body element at the very top that contains all of the code. And the body contains two elements. It contains the h1 element and it contains the unordered list element. The h1 has this text list that we fed into it. On the unordered list side, the unordered list actually has two list items in it, one of which we fed the word 1 and one of which we fed the word 2. All right, and so now we've actually are able to kind of graphically represent this HTML, this set of HTML elements with the tree on the right hand side. And so if we're and so this looks a bit like the previous page of code, and we'll talk about this in 1 second. Before we go any further though, line 1 div, that's probably the most common HTML element that you're going to see floating around. Div is kind of like body in the sense that it's just like a very generic like container, right? It's like an empty box, right? It's like, oh, what's a cardboard box? What can a cardboard box hold? Well, pretty much anything, right? And that's what a div tag is. A div is just like an empty container for things. Um, One of the things I will notice here is that the code on the left-hand side and the right-hand side are the exact same. If I feed into a computer, it will render the same exact way. From a text perspective, they have every character is the same. The only difference is on the left-hand side, nothing is indented. But on the right-hand side, the middle three lines are indented. And the reason why those are indented is because it makes it very easy for us to very quickly visually see that, hey, lines 2, 3, and 4, those elements are actually, they belong inside the div container. And we know that that's the case because the div starts on line 1 and it ends on line 5, right? That means every element in between those two tags belong to that tag. And so code indentation is something that's actually going to become a very useful tool for us to really quickly understand, you know, which like what's the relationship between these elements, right? Where does this element belong to? And usually the child element is going to be indented 1 unit relative to the parent element. And so the code on the left will run properly, but it's just very painful to understand, or at least a lot more difficult to understand, whereas the code on the right is a lot more easy to read. Yep. So parent and child helps us understand the relationships of elements relative to each other. Now let's talk about the positioning of the elements on the page as a whole. And to do that, we have to talk about block and inline elements. Okay. Here I have two elements, two paragraph elements. They both say hello. I put them on the same line, but when I render them on the page, notice how each hello goes on its own line. Conversely, here I have something called a span tag. A span tag is very much like a container tag too, except the only difference is here I have two span tags. I put them on different lines, but once I render them, notice how even though I wrote them on two different lines, they actually show up on the same line. All right, they're trying to squeeze in on the same line. And so this highlights a very big difference, right? And this is because spans are what we call inline elements, whereas this p tag are what we call block elements. And so the difference between an inline element and a block element is very simple. A block element will kind of preemptively say, give me the entire row of text, right? It will take up the width of the entire page by default. And so here on H1 and H3, which are block elements, notice how the words dog breeds and small dogs, they're not that long of words. We could easily fit both words on the same line. But block elements by default say, all right, before we even get started on how long this word is, give me the entire line at a minimum, right? I might need more lines later on, but give me the entire line at a minimum. Span tags or inline elements on the other hand, actually try their best to take in only the amount of space that they need to squeeze in the text, right? So here I was able to squeeze all three span tags on the same line. Now, if I want to add another span element, it might be too wide for what space is left on the page, and so in that case, it might automatically get pushed back to the next line. But the short of it is that inline elements will always do their best to try to fit in on the current line if at all possible, whereas block elements will take up the entire width of the row. And this will become very important when we think about kind of web page design and spacing, right? It may seem like the block elements take up too much excess space, but if I'm making a header, if I'm trying to do some creative with the layout of the page, maybe I may actually want that effect. So it's not like one is good or one is bad. It's just they're used for different purposes because they kind of control the space around them differently. Any questions so far before I move on to the next section on attributes? I think you're talking, Eric, but I can't hear you. Oh, there we go. Yeah, now I can hear you. Yep. Yeah. Yeah. The headers tend to be bolder and larger in text size. Although when we talk about CSS, you'll see that we can also modify that as well if we choose to, right? We can make it even more bold or even bigger text if we wanted to. Yeah. Sorry, you're trying to differentiate between what? Between what? Yeah, sorry, but you before that you said you were trying to differentiate between what again? So you're trying to differentiate between H1 through H4? Yeah, yeah. So H1 and so the headers are usually meant for like kind of big text, right? Body, divs, and spans are all container tags. And so span is generally used because it is an inline element. Divs are kind of the catch-all. People use that for almost everything. It's a block element. And then body theoretically should only be used once on a given page. And it should be used to hold everything. So there's a slight nuance to why they're being used, when and why they're used. But for our purposes for now, you can probably use them fairly interchangeably as long as you can get the inline and the block differentiators set up correctly. Cool, cool. Yeah. Any other questions from anyone? Cool. Well, there are no other questions, and we'll move on to attributes, and then we'll actually going to be actually almost done with this material. So we're going to this fairly quickly. Um, Attributes are essentially ways for us to add extra pieces of information to our elements. And the two most common ways to do this, one is called ID and one is called class. The difference between the two is, so rather before you start, we add attributes to the code, to the HTML elements in the open half of the tag. So here I have a p tag that says hello world, but notice how in the p I have my p, but I have a space, and then I have a field called ID equals, and after that I put in a string value or whatever value I want the ID to be. And then similarly for class, I can have multiple elements, but now instead of putting ID, I can put class equals and then the string value of whatever I want the class value to be. The main difference, so why do we want to add extra attributes? The short answer is because sometimes we need to pass extra information to the elements, and then sometimes it's because we want to also make it easier for us to group these elements together. And so for now, when we talk about ID and class, it's usually more in the latter case, right? We want to find some way to group these elements together. The difference between ID and class is you can think of ID as like a social security number, whereas class could be like an ethnicity or a gender. In the sense that an ID there should only be one person with that ID on the given in a given country, right? Similarly, on a given page, there should only be one element with that ID value. On the other hand, the class value, there could be many multiple things with that same class value. And so if I was to say, hey, I want on the top half of this, if I say I want to change that element's text to yellow, but I want to change only that element, well, I could select it by saying, hey, find me an element with the ID of just me. On the other hand, on the bottom half, if I want to say I want to select all three of those elements, I could just say, hey, give me all the elements with a class value of all of us. It's a nuance that when we talk about the CSS tomorrow, it'll become a lot more clear. But for now, just note that the reason why we're bringing this up is because we want you to know that for any given HTML element, you are also able to add more. You are always able to add more information and more attributes, more properties to that given element. So ID and class are just two ways for us to do that. The other way to do that is through our old friend, the links or the image tags and the link tags. If I look on the top half of this page, I'm dealing with a link tag. The A tag is essentially is a link tag, and links obviously I think everyone hopefully should be familiar with. It looks a bit like what we see on the right hand side, right? The link tag, it starts with an open link tag, a closed link tag. In between, we put in the text visit Google, and when I see my output, yeah, the text says visit Google. But for a link tag, I also need to give it a special attribute called the href attribute. And the href attribute basically says, when someone clicks on this link, what website do you want us to redirect it to? All right, does everyone see that on the first line? We have an a tag space, and then we have href equals, and in this case I gave it a URL of https www.google.com, right? And so this is just another way in which this is another way in which attributes, additional information sometimes are imperative to how that particular tag works. Before I had a random kind of line of text and I say, hey, call this an ID or call this a class. Here I have a link and it needs an href to know where to redirect the link once someone clicks on it. And so attributes sometimes are very mission critical to the tag itself. And similarly down the bottom for our image tag, now we're giving it an attribute of src. All the image tag in JavaScript does is it says, I need to show an image, tell me where is this image being stored. And so in this case, in the src attribute, I actually need to give it a web address, whether it be on my computer or somewhere else on another computer, of where the image is actually being stored. And so if I don't give this image tag an src value, the image tag will not load up the correct or the proper image. Yeah. Attributes can be a little bit confusing. Sorry, Holly, go ahead. Um, well, so the A tag is the tag that allows you to create links. So it allows you to click on this link and go to another page. If I did that with a P tag and I gave it an href, the P tag wouldn't know what to do with the href. An A tag would. It would say, oh, great, you gave me a website. Let me now redirect anyone who clicks on me to this other website. Yes. Yep, sorry. Any other questions? Yeah, I can hear you. Yeah, yeah. The src basically says where is this image being stored, right? So if I don't tell it where it's being stored, then there's no way it can show the proper image. Yeah, yep, yep, yeah. And when you do the reading in the workshops later today, you'll definitely get a lot more coverage of this material again. Once again, we just wanted the goal of the lecture really is to kind of give you a high level overview of, hey, this is how everything kind of comes together. The reading will give you a little more detail around, like, oh, like, for attributes, how do you write it? What does it look like? What are kind of some special properties of it? But for now, we just make sure that the big picture is somewhat clear around how the HTML parts of a website comes together. So some quirks around HTML. Oh, sorry. Do you have a question, Eric? Sorry, I missed that. Oh, okay. Okay. So yeah, yeah. You're welcome. So some quirks around HTML. The first one is that white space doesn't really matter. And what do we mean by that? Here on the left-hand side, you'll see that we actually wrote HTML a variety of ways, right? We wrote it with one space in the middle between hello and world. We wrote it with multiple spaces, and then we've written it indented on its own line. In all three cases, the hello world that gets rendered looks the exact same. And so HTML has this really kind of nifty thing that says, I'm gonna look for white spaces in the between whatever text you pass in. If there's more than one sequential white space, I'm just going to take those white spaces and collapse all of them into a single white space. That's why at line 2, those white spaces don't show up, right? All the white spaces get combined into a single white space. Similarly, if your code has any white space before or after it, in this case, in the third example, we have a new line return before and after the text. HTML just more or less ignores that. And so this gets another kind of interesting and somewhat powerful idea behind HTML, which is that the way that you write the code may not necessarily be how the code looks once it's being rendered, right? You can put all the white space you want on the HTML side of it, but it doesn't mean that HTML is going to render the white space. And so to that extent, that leads us into the second, um, the second thing. And also, yeah, this is the same example that we saw earlier, right? Whether or not the elements show up on the same line or on different lines has nothing to do with how you write the HTML. It has everything to do with whether or not you're dealing with block elements or inline elements. In this case, P tags are block elements, and so they will always take up the entire width of the row. And so it doesn't matter how you organize the HTML itself. When you render that on the page, all the elements are going to render. Each element is going to render on its own row because that's what the property of the P tags are. And that leads us to our second kind of quirk, is that HTML sometimes is a bit too forgiving, in the sense that in a lot of programming languages, if you make a syntax mistake, if you do something wrong, the computer will just yell at you and say, "Hey, this is wrong." HTML, for better or worse, will never yell at you, but it will actually do its best to try to render the code the way that it thinks you want it to. But the sad truth is it's probably more often wrong than right. And so one of the kind of more tedious parts of HTML is that you can't just run it and expect it to work properly, even if nothing breaks. You should always go look at the code and make sure the web page looks the way that you think it should look. Right? There's no automatic failures for bad HTML code. The worst case is those elements won't show up, but, and this is pretty key, the code will not break. And so you always need to do a manual check just to make sure that the end result is what you think it is. The last thing we'll talk about with comments, with HTML is just around the idea of comments. Comments are essentially messages that you can leave in the code for other developers. When a computer sees a comment, it more or less just completely skips over it, and it doesn't try to run it or interpret it or do anything with it. And the way to write a comment in HTML is with these tags that you see above in the header and also in the example here, right? It's like the open caret, exclamation mark, dash dash, and ends with a dash dash, close caret. Here I have a p tag of hello, I have a long comment in the middle, and then I have the p tag world on the bottom. When I run this code, the computer more or less ignores that entire comment and it just renders the first hello and then followed by the second element of world. Okay, so once again, comments are not meant for computers. They're just a way for you to leave other messages to future human programmers who will look at your code. And then last but not least, some common mistakes that folks make with HTML. Sometimes people forget to close tags or quotes. Once again, HTML will not tell you if something's wrong. It will just not show the right thing. And so usually the way you troubleshoot this is by looking at the result, being like, this looks wrong, and then going through your code trying to figure out why those elements didn't show up properly. Also, and this is quite common and silly, but it happens more often than you would think, people just misspell stuff, and that's a very common mistake, and that just comes along with more practice and a closer eye for inspecting code. And then last but not least, people also fail to indent properly sometimes too. Once again, when you don't indent properly, it doesn't affect how your code runs, but what it will do is it will make your code a lot harder to read for future human programmers. And so that's more or less all the materials that we have for today in terms of the lecture. We're now going to break you guys off into doing workshop problems, which are a mix of reading and live coding examples